All right, number 11. Moving into the half angle formulas now, so I've added those to my card here, so it'd be really handy to have a card like this where you've got all the formulas, even, to use on the test, where they're right there in front of you. You don't have to keep going to look them up. All right, so in this one, we are looking for the secant of the half angle, half of A, or A divided by 2. So I want to find the secant of A divided by 2. Now, real quickly, noticing that there is no secant here, doesn't need to be. Secant can be written as 1 over cosine, so this would be the same thing as 1 over the cosine of A over 2, which I have a formula for now. The cosine of A over 2 can be, we don't know if it's going to be positive or negative yet. We'll figure that out. I could go ahead and figure it out, but and we'll do that in a minute. Let me go ahead and write the formula down. But it's the square root of 1 plus the cosine of the angle divided by 2. Don't forget the 1. I about forgot the 1 on top of that. So I'm just, the cosine of A over 2 is being replaced with this. This is all under 1. Okay, so is the angle going to be positive or negative? So the angle is in quadrant 4. Let me draw it over here. In quadrant 4. So the angle falls in this quadrant. The cosine is 1/2. That's adjacent to hypotenuse. That means, do the Pythagorean theorem, this side is going to be negative square root of 3. So it's 4, square all the sides, 4 and 1, and then subtract 4 minus 1 is 3, square root of 3, but it's below 0, so negative 3. Any angle that falls in quadrant 4 is between 270 degrees and 360 degrees. So the angle A is greater than 270 but less than 360. So the half angle would fall between half of 270 and half of 360, which is 135 and 180. Well, between 135 and 180 is, here's 135, here's 180. It's falling in quadrant 2. So for an angle that's in quadrant 4, its half angle would be in quadrant 2, between 135 and 180, which means that its cosine is going to be negative in quadrant 2, so we know this is going to be a negative. All right, and then so we'll go ahead and finish out with 1 over negative square root. It's 1 plus the cosine of, well, the cosine was given to me, so I really didn't even need to draw it. 1 plus the cosine of A, which is 1/2, and it's over 2. Okay. So I end up with, let's simplify a little bit here, 1 over, think this is 2/2 plus 1/2, so it's going to be 3/2 over 2, which could turn into 3/2 times 1/2, which would be the square root of 3/4. I could even, since the square root of 3 is not a perfect square, so I'll leave that under the radical, but the square root of 4 can come out. And then again, 1 over a fraction, all that does is reciprocate the fraction, so it's going to end up being 2 over square root of 3. Now, oh, and don't forget that I've lost my negative sign here. Bring that negative along. Would web assign take it here or here or here? Maybe, I don't know. You could try it and see, but I went ahead and simplified it a little bit better than that. All right, my number 12 asked me for secant again, like number 11 did, so I'm not sure if they're all like that or if this is just the random generator that spit the same one out twice, but we'll go ahead and go through it again. Secant of A over 2. Again, 1 over, it's the same thing as 1 over cosine of A over 2, and the cosine square root of 1 plus cosine of A over 2. Is it positive or negative? Well, this time A is in quadrant 2. So it's over here. And the sine is 5/13, which means the adjacent side is 12, negative 12, since it's in quadrant 2. But bottom line is the angle A is in quadrant 2, which means it falls between 90 degrees and 180. So its half angle would fall between half of 180, which is 90, and half of 90, which is 45. So it would fall in this range right here at quadrant 1, which means it's going to be positive. So, all right, and so the cosine of, so it's 1 plus the cosine of A, so angle A, its cosine is negative 12/13. And then again, it's just a little simplifying from there. So 1 over square root of, think of this, 13 thirteenths minus 12 thirteenths, so that's 1/13 divided by 2. I'm going to go ahead and do times 1/2, so save me a step there. So it's going to be 1 over the square root of 1 over 1 times 1. 13 times 2 is 26. Square root of 1 is 1. It can come out of the radical. 26 will have to stay under. And then again, 1 divided by a fraction just reciprocates a fraction, so it turns this into 26, square root of 26 over 1, which is just the square root of 26, and I'm done. Best, most simplified answer. All right, my number 13 asked me to find the sine of the half angle B, sine of B over 2. So sine of B over 2, the formula says it's plus or minus, we'll figure out which one it is in a minute, of 1 minus cosine of B over 2. Okay, well, if they give me the sine of B, not the cosine, so let me draw it out here in quadrant 3. If the sine is -1, the opposite to the hypotenuse, doing the Pythagorean theorem, this would be 25 minus 1, which would be 23 or 24, so this would be negative square root of 24. And in quadrant 3, the angle falls between 180 degrees and 270, so the half angle would fall between half of 270, which is 135, and half of 80, which is 90. So if you take the half angle of anything in this quadrant, it's going to fall between 135 and 90 in quadrant 2. And cosine in, or I'm sorry, we're looking for sine. Sine in quadrant 2 is positive, so this is going to be positive. All right, so 1 minus cosine. The cosine of B is adjacent over hypotenuse, so negative square root of 24 over 5 over 2. All right, 1, go ahead and make that 1 plus square root of 24 over 5. I should have done, I'll tell you, let me back up. Let's think of this as, save the step here, think of this as 5/5 plus square root of 24/5, which would make this 5 plus square root of 24 over 5 over 2, or times 1/2. It's going to turn this into the square root of 5 plus square root of 24 over 10. And, you know, that's about as good as you're going to do with that. I would just leave it that way. Okay. All right, number 14 says use the half angle formula to find an exact value for the cosine of 22.5 degrees. Okay, so what I'm going to do using the half angles is I am going to let theta be 45 degrees. And so when I go to do the cosine of theta over 2, that angle is going to be 22.5 degrees, because 45 divided by 2 is 22.5 degrees. 22.5 is half of the angle theta, 45. And so I can then replace cosine of theta over 2 using my formula here with 1 plus cosine of theta over 2, which, and again, it's a first quadrant angle, so it's positive, so I don't have to worry about the sign. But the 1 plus cosine of theta is 45 degrees over 2, and the cosine of 45 degrees is square root of 2 over 2. And I'll go ahead and think of this as 2 over 2, so let's write this as 2 plus square root of 2 over 2 divided by 2, or times 1/2. Again, becomes 2 plus square root of 2 over 4 under the square root. And you could go, since 4 is a perfect square, you could actually pull that out of the radical and just say 2 plus square root of 2 on top with 2 on the bottom if you want to bring the square root out. Okay. Okay, the last one is an identity, another identity. This is actually a pretty easy one though. Again, it's done for you. All you got to do is fill in the blanks. So, and it even tells you on, I didn't write this on the card, but it says that we begin by using a half angle formula on the left side of the equation. We can then separate the expression into two fractions and simplify using the reciprocal and ratio identities. And so they basically tell you exactly what they did. And so the tangent of b over 2, straight, and you know they used one of these, but you know if you look at how it's stated here, 1 minus, so this must be cosine x. So this is coming straight from the half angle identity for tangent. And then it tells you, then they split the, we then separate the expression into two fractions. So they separate into 1 over sine b minus cosine over sine b. So this is also, and the rest of it's done for you. 1 over sine is cosecant, that's a reciprocal identity, and cosine over sine using the ratio identity is cotangent. And that's all there is to that one.